Hello and welcome everyone, guys. So now we continue our second class of Thermodynamics PYQ of IIT JAM. So in last class we have discussed or at least six questions. Now in this class we discuss more. So our first question today is mm, that we have accident contents of 16 gram of oxygen. The work is done when the gas is compressed to 75% of the original volume at the constant temperature 27 डिग्री सेल्सियस। So हमें वर्क डन कैलकुलेट करना है। ओके, 16 ग्राम ऑक्सीजन का, 16 ग्राम ऑक्सीजन एंड 75% वॉल्यूम जो है इनिशियल वॉल्यूम का वो कंप्रेस्ड हो गया। सो लेट्स सपोज और इनिशियल वॉल्यूम इज वी। सो इफ वी आई इज इक्वल्स टू वी, सो वी फाइनल हमारा क्या होगा, जो रिमेन 75% तो क्या हो गया हमारा, कंप्रेस हो गया। सो द रिमेनिंग वन, सो इट विल बिकम 3/4 वी। ओके एंड आर गिवन है। So now we know the work done. Work done W is nRT ln V2 by V1. So here we have R, temperature T, because at 27 degrees Celsius. So temperature, let's take temperature 30 Kelvin. Okay. So we don't have here N. So to calculate N, here I given that 16 gram oxygen. So I know that oxygen one mole oxygen molecules have 32 grams of mass. So 16 ग्राम मास के लिए कितना ऑक्सीजन का मॉलिक्यूल होगा, 1/2 मोल ऑक्सीजन के molecules have 16 gram mass. So n is equals to, I get 1/2. Now uh, n is equals to 1/2. So put the formula, putting values in equation, we get work done W is equals to n is equals to half, R is equals to 8.314, and temperature is equals to 300 Kelvin, and ln V2 that is 3/4 of V, and V1 is equals to V. So this is cancel out. So this will is equals to 150, 8.314, and ln 3/4. Since we know ln 3/4 is equals to, so ln 3/4 is equals to minus 0.28. Okay. So net work done is equals to 150 into 8.314 into minus 0.28. So by calculating these all value, we get finally approx minus 349 joule. So this amount of work done required for to compress the gas, oxygen gas, uh, for the 75% of initial volume. So this is the answer. So now we move to our next question. So this is our next question. In this question, we have again considered two identical finite isolated systems. Contains heat capacity C. Two systems and both contains heat capacity C at a temperature T1 and T2. And it is also given that T1 is greater than T2. Engines works between them until their temperature becomes equal. Okay, taking into account that the work performed by the engine will be maximum if the process is reversible. Okay, process जो है reversible है. Equivalently, the entropy change of the entire system is zero. Okay, so the value of W maximum is, so we have to calculate the value of W max, calculate करना है हमें. So now, so the engine work between their temperature. Okay, so suppose we have given T1 and T2 temperature of two isolated systems. So let's suppose, let the temperature final temperature be T final. Okay, ये हमारा final temperature होगा after the completing the work. So the process continues until T1 drops to T1. Okay, so I have to write all details. So the process continues continues until T1 drops to T final, because T1 is higher than T2, so T1 to T final, and T2 rises, क्योंकि T2 थोड़ा कम है तो T2 बढ़ेगा टेम्परेचर और T1 घटेगा टू T फाइनल. सो दोनों जो टेम्परेचर्स होंगे वो एट द एंड T फाइनल पर पहुंचेंगे. सो द हीट कैलकुलेट करते हैं. सॉरी, हीट. सो हीट Q1 जो होगी मेरे पास वो होगी C T1 माइनस T फाइनल, एंड Q2 सेकंड की वजह से हीट जो होगी वो होगी T final minus T2. Okay, and now we know the work done due to Carnot cycle is equals to Q1 minus Q2. So work done is equals to Q1. C is constant. We're taking account T1 minus T final minus T final plus T2. So C is equals to T1 plus T2 minus 2 T final. So this is the maximum, this is the work that is done by these engine. But uh, we have to maximize the work done. So to max, sorry. So to maximize it, now we continue. Consider the heat is given out and taken at mean temperature, because there is no reservoir is attached to the system. Okay, so due to uh, any reservoir is not attached to the system, because यहाँ पे system के साथ कोई reservoir अगर attach नहीं है, so क्या होगा कि जो given heat है और जो एक mean temperature तक जाएगी. Okay, so for consider heat is given out and taken at mean temperature, because there is no reservoir. Okay, there is no reservoir. So for Q1 मीन टेम्परेचर क्या होगा, मीन टेम्परेचर तक जाएगा, बिकॉज टेम्परेचर उनका एडजस्ट होगा. T1 प्लस टी फाइनल बटा दो, एंड फॉर Q2 ये वापस मीन टेम्परेचर तक जाएगा, इसके लिए होगा T2 प्लस टी फाइनल बटा दो. सो फॉर मैक्सिमम वर्क वी नो, फॉर for maximum work, maximum work Q1 by Q2 is equals to mean temperature of first system upon mean temperature of second system. Okay. So now Q1 upon Q2. So it will like Q1 we calculate here, Q2 we calculate here, mean temperature we calculate here. So now this will look like T1 minus T final upon T final minus T2 बराबर T1 प्लस T फाइनल वो डिवाइड में था वो कट जाएगा, इधर C था जो C का दोनों में से कट गया। ओके मैं पूरा ही लिख देता हूँ एक बार, अपॉन अपॉन 2 एंड T2 प्लस T फाइनल अपॉन 2, 2 से 2 कैंसिल आउट, C से C कैंसिल आउट। So now our final terms will look like, by solving these two we get that T1 minus T final multiply T2 plus T final is equals to T1 plus T final multiply T final minus T2, and by calculating this we get that T final is equals to root T1 T2, root T1 T2. So now put this, suppose this is equation 1 and so this is equation 2. So from equation 1 and 2 we get work done is equals to C T1 plus T2 minus 2 root T1 T2, and we can write it like C comma root T1 minus comma root whole minus root T2 का whole square. So the net work done required for the maximum work done required for the system is this. So this is, I think this fourth one is the right answer. Now we move over next question. Okay. I hope you got it. Okay. So now in this question, given that if there is 10% decreases in the atmospheric pressure at the hill compared to the pressure at sea level, uh, let me sea level, then the change in the boiling point of water is okay. हमें ये कैलकुलेट करना है कि कि अगर कोई एक पर्सन है जो सी लेवल की बजाय किसी एक हिल पर गया और हिल पर उसको 10% डिक्रीमेंट किस में आ गया, उसके प्रेशर में आ गया, तो ऑब्वियस है बॉइलिंग पॉइंट में भी कुछ ना कुछ वाटर के एटमोसफियर प्रेशर में 10% का डिक्रीमेंट आया तो वाटर के बॉइलिंग पॉइंट में इस हिल पर कितना चेंज होगा, ये हमें कैलकुलेट करना है। सो नाउ सॉल्यूशन लिखते हैं हम। मैं गिवन है सबसे पहले क्या क्या गिवन है हमें, 10% डिक्रीमेंट, 10% डिक्रीमेंट गिवन है हमें, ठीक है, एंड सी लेवल ऑफ द बॉइलिंग पॉइंट, एंड बॉइलिंग पॉइंट ऑफ वाटर हमें पता है टेम्परेचर कितना है, 100 डिग्री सेल्सियस पे वाटर बॉईल करता है, मीन्स 373 केल्विन पे वाटर बॉईल करेगा। हमें लेटेंट हीट दे रखी है दैट इज 2270 किलो जूल, मीन्स 10 की पावर 3 जूल पर केजी लेटेंट हीट फॉर द वेपराइजेशन। Change in specific volume, boiling point V. Okay, change in specific volume is equals to V2 minus V1 दे रखा है हमें 1.2 मीटर क्यूब पर kg. Okay, so now we know by the equation Clausius-Clapeyron equation, that is equals to dp by dt is equals to L V2 minus V1. So by this equation, we can manipulate that dP is equals to L dt over T, okay, V2 minus V1. And we have to calculate the change in temperature. So dt को एक तरफ रखते हैं, बाकी टर्म्स को दूसरी तरफ भेज देते हैं. So T V2 minus V1 dP over L. So now यहाँ हमें T पता है, V पता है, dP पता है. dP 10% डिक्रीमेंट ऑफ, बिकॉज एटमॉस्फेरिक टेम्परेचर हमारे पास कितना है, अप्रोक्स P एटमॉस्फेरिक अप्रोक्स हमारे पास 10 रेज़ टू द पावर 10 रेज़ टू द पावर 5 एंड L हमें पता है. सो नाउ dt is equals to temperature is equals to 373 into. ओके ओके सॉरी, टेम्परेचर हमें जो है यहाँ पे डिग्री सेल्सियस में कैलकुलेट करना है. सो वी पुट ओनली 100 डिग्री सेल्सियस मल्टीप्लाई 1.2, that is change in specific volume, that is given 1.2, and change in dp, that is 0.1 of 10 raised to the power 5. ये चेंज हो गया. ओके, ओरिजिनल 0.5 था, वो 10 रेज़ टू पावर 5 था, बट उसमें चेंज कितना हुआ 10% का. तो 10% को हम इस तरीके से लिख सकते हैं 0.1 एंड L is equals to 2270 over 10 raised to the power 3. So now calculating the all these value, we get the final answer, that is 1.97 degree Celsius approx. So this is the change in the temperature due to uh, height. Due to height, if someone at the sea level, so its boiling point is equals to 100 boiling point of water, and boiling pressure at sea level is equals to approx 10 to the power 5 atmosphere. Now, if someone goes at the top of the hill, so here atmospheric pressure decreases and boiling temperature जो होगा वो भी चेंज हो जाएगा. Okay, so now I hope you got it. Now we move our next question. Now we move to our next question, that is question number 10. An isolated box is divided into two equal compartments. Okay, दो equal compartment में divide हो गया. One compartment contains a van der Waals gas. Okay, while the other compartment is empty. The partition between the two compartments is now removed. After the gas has filled the entire box and equilibrium has been achieved, which of the following statements are correct? सो यहाँ पे हमारे पास ये पूरा कंपार्टमेंट है और जो कि आइसोलेटेड है. ठीक है, ये पूरा कंपार्टमेंट जो कि आइसोलेटेड है. सो आइसोलेटेड के केस में हमें ये पता होता है कि चेंज इन हीट जो होती है वो 0 होती है. ठीक है, उसके अलावा वान डर वाल्स गैस है, जो हम कंपार्टमेंट का ये वॉल हटाएंगे तो वॉल हटाते ही ये क्या होगा, इसका फ्री एक्सपेंशन होगा. ठीक है, फ्री एक्सपेंशन होगा. फ्री एक्सपेंशन में क्या होता है, फ्री एक्सपेंशन में जो प्रेशर होता है, प्रेशर that is also 0. dp is also 0. So now, oh, okay, sorry, dp not p is equals to 0 free expansion में. Now we know that by the first law of thermodynamics, it is dq is equals to du plus dw. So du is equals to dq minus pdv. pw को pdv लिख सकता हूँ. So du is equals to dq 0, p की 0, dv भी 0, तो du is equals to 0. So my u is equals to constant. Okay, u is equals to constant. So अब ऑप्शन पे आता है इंटरनल एनर्जी ऑफ द गैस हैज नॉट चेंज. सो सही है, इंटरनल एनर्जी क्या आएगी, रिमेन कांस्टेंट. इंटरनल एनर्जी कांस्टेंट रहेगी मेरी. उसके अलावा इंटरनल एनर्जी ऑफ द गैस डिक्रीजेस, नहीं नहीं होगा। टेम्परेचर ऑफ द गैस इंक्रीजेस, टेम्परेचर ऑफ द गैस डिक्रीजेस। नाउ because of the free expansion, if p is equals to 0, p tends to 0, so अगर p tends to 0 होगा तो ये p, because of p tends to 0, टेम्परेचर जो होता है तो टेम्परेचर भी फ्री एक्सपेंशन में डिक्रीज होता है। फ्री एक्सपेंशन में, फ्री एक्सपेंशन में टेम्परेचर डिक्रीज होता है। सो डी ऑप्शन इज करेक्ट, नॉट सी। सो ए एंड डी आर करेक्ट। Okay, so now we move on next question. That is question number 11. Okay. So in this question, I have given that we have given consider a Carnot engine operating between temperatures 600 Kelvin, 400 Kelvin. The engine performs engine performs 100 joule of work per cycle. 100 joule of work per cycle. The heat in the heat in joule extracted per cycle from the high temperature reservoir. Okay, so now we know uh, by the Carnot engine we have a source T1 temperature source and system, that is work, and the sink. Okay, T2, ये T2 ये जो होता है सोर्स वो हाई टेम्परेचर पे होता है एंड सिंक जो होता है लो टेम्परेचर पे होता है। सो नाउ T1 हाई टेम्परेचर से हमारा इंजन जो होता है वो Q1 एनर्जी, Q1 टाइप्स हीट अब्सॉर्ब करता है एंड Q2 ऑफ हीट जो होता है वो रिजेक्टेड कर देता है। सो तो इन दोनों का बीच का जो डिफरेंस है वो कहीं में जाता है हमारा वर्क में, Q1 माइनस Q2। सो वर्क इतना अमाउंट ऑफ वर्क डन कर देता है, Q1 अमाउंट ऑफ हीट लेता है, वर्क डन परफॉर्म करता है Q1 माइनस Q2 और Q2 रिमेनिंग दे देता है। सो हमें टेम्परेचर गिवन है T1, हमें गिवन गिवन डाटा है हमारा दैट गिवन है temperature T1, that is 600 Kelvin, temperature T2 400 Kelvin, and work done, that is 100 joule, 1000 joule. So we have to calculate Q1. Q1. So now we know by the efficiency of Carnot engine, that efficiency is equals to uh, W upon Q1. Okay. So W is equals to, okay, W by Q1, and we can write it Q1 minus Q2 by Q1. But for here, I only use W by Q1. Okay. And we also know that efficiency is equals to 1 minus T2 by T1. So this is, suppose this is equation 1, this is equation 2. So from equation 1 and 2, from equation 1 and 2, I got that 1 minus T2 by T1 is equals to W by Q1. So here I given that 1 T2 given 400 Kelvin, T2 600, W 1000 and Q1 we have to calculate. So now I can solve it like this: 1000 by Q1. So this is 3 minus 2, 1 by 3 is equals to 1000 by Q1. So now Q1 is equals to 3000 joule. So this amount of heat absorbed by the system from the source at high temperature T1. Okay, I hope you got it. It's a easy question. Now we move to our next question. I think it will last question for today's session. Okay. So in this question, given that starting with equation this TDS, DU, PDV, and using the appropriate Maxwell relation with the expansion from heat capacity Cp, useful in the derivative del P by del T at a constant entropy for a substance can be expressed in terms of its specific heat Cp, density rho, coefficient of volume expansion beta, and temperature T final for ice is equals to uh, s- and Cp is equals to 2010 joule per kg. Rho and these all are data are given. So we have if del P by del T at S is equals to this value n times 1 10 to the power 7 Pascal per Kelvin, then value of n is so हमें value of n कैलकुलेट करनी है. So now, so मैक्सवेल इक्वेशन जो हमें पूछी है वो del p by del p by del t at s. So now we know del p by del t by the Maxwell equation. It is also equal to del s by del v at constant pressure. Okay, so we have to calculate it in and manipulate the right hand part and generate the equation in the given data form. So now we can write it like del s by del t and del t by del v at constant pressure. ठीक है. Now del s by del t at constant pressure and del t by del v at constant pressure. If I multiply it by t and here divided by t, so what do I get? TdS जो होता है वो मेरा क्या होता है? dq. I know ना, dq upon del t at constant pressure and 1 by t del t by del v at constant pressure. Now I know that since we know that dq is equals to mcp dt, ये हमने पढ़ रखा है पहले. सो यहाँ से अगर मैं del q by del t एट कांस्टेंट प्रेशर लिखूं तो वो आ जाएगा मेरा mcp के इक्वल. ओके, सो नाउ del p by del t at constant entropy s is equals to mcp uh, by t and del s by del v. Okay, sorry, del t by del v, del t by del v at constant pressure. Now now uh, we know rho is equals to mass type by volume. Okay, so m की जगह लिख दो rho times volume. So this equation look like rho cp v by t and del t by del v times p. Okay, so now I can rearrange it like rho cp by t and 1 upon del v by del t 1 upon v times p and and this is del p by del t at s. And since we know that volume expansion beat volume expansion volume expansion beta is equals to 1 upon sorry I, I 1 by v del V by del T at constant pressure. This is equal to volume expansion. So now put it here. We get del P by del T S is equals to rho Cp T upon beta. Okay. So here we all get values. Rho की वैल्यू हमें given है 10 raised to the power 3 kg per meter cube. Cp given है हमें. Cp जो है वो कितना ये रखा है 2010 जूल पर केजी एंड टेम्परेचर टी दे रखा है 270 केल्विन एंड बीटा हमें गिवन है 1.6 इंटू 10 रेज़ टू द पावर माइनस 4. So now put the value del P by del T here as I get 10 raised to the power 3, 2010, 270, 1.6 into 10 raised to the power minus 4. And by calculating the all these values, uh, by solving this, we got n into 10 raised to the power 7. So now you can calculate it, solve it, and get the value of n. So now this is all for today. Stay connected for the next questions. Okay, I'll promise you I will keep all the questions here. I will solve all the questions. Thanks.